You'll probably be working in groups on something later today, so pay attention so your group member's not carrying the load. We're going to first go to, bless you, assignments.
Should we open our computers?
No. You can just watch now. I'm going to start with the long division problems. And I'll give you at this age, many times I'll give you the answers and the solutions to worksheets or tell you how to find them or whatever, because I expect you to be, a lot of times you want to see if you're doing it right and you can move on. If you're doing it incorrectly, some of the things I send you actually are almost as good as Delta Math. They just didn't have good long division on Delta Math, so that's why I chose this one. But I'm just going to screenshot some of them in. Forgive me if I do one that you did with me, those of you that came by for help. But it probably is not going to hurt to go over it. You will find this necessary on Friday, so I wouldn't wait too long to figure out how to do this. In fact, you can know today how to do it. We'll do all of these maybe if we have time. If I don't do them all, you've got the solutions after, like click right there and they do it like I do it. They just don't show their minus sign, but they're subtracting mentally. Dakota?
Can I grab a tissue?
Yeah. Okay, so here's, all right, so here's the first one. We'll move it down here. All right, so I'm going to take, now what you've got to do is go x cubed minus 4x squared plus 2x plus 5. Once it starts with a power like x to the third, you've got to have x to the second and x to the first and a number. Okay, if it starts with x to the fourth, you've got to have an x to the fourth. If it skips an x to the third, you've got to put in a 0x to the third. You've got to have a something x squared. You've got to have an x and you've got to have a number. If one of those is missing, you put placeholders of zeros in there. If you don't do it, you'll find out that you forgot because your long division won't work out. It won't line up correctly. I'll show you what I mean so that you're comfortable with that. So don't panic if it's not lining up. It's kind of a good thing. It's an easy fix. You're like, oh yeah, I forgot my 0. Okay? I'm going to divide this by x minus 2. Okay? It's very easy, but I tell you, it's definitely one of those things you've already probably encountered in your algebra classes before in geometry, where you watched the teacher do it and you thought you knew it until you got to the quiz or the test and you couldn't do it yourself. So make sure that you practice these. You've got the link for this one. So anyway, let me move this out of the way. You have to have everything accounted for in the numerator and the denominator. This one starts with x to the first. It's not really oriented over there, I found out the other day, so I'll try to write right here. But this also has to have everything accounted for. But that started with x to the first, so all it required was a number after it. It goes cubed, squared to the first power, and then a number. Any of those are missing. Once it starts, you need to put in a 0 coefficient, which did not happen here. Okay? Now, I did this with a couple of you that came by, and I think it's good to look at. We'll scroll down and see what Harry looks like here, and then we'll
the same problem.
yes, in just a second. So there he is in his like campy shirt. Okay, so let's write on this. All right, so just pause. I'm going to go back to that slide in a minute. But this seemed to help some people, and it's really not the pre-calculus teacher's job to teach long division. But I don't think I've taught pre-cal most of my career, which is very long. And I feel like I always have to go back over a few things like logarithms, long division, always, no matter what fabulous teacher taught before me, no matter if I was the teacher that taught it to you, or which is the case for some of you. So it's very normal to have to spend a few minutes on long division. But I started out like this. Suppose I have 4,214 divided by, let's say 10. okay? What I think all of us do is we realize we want to match that with that before we get going any further. And don't we all think of 4? 4 might not have been the right number, but aren't we just sort of estimating where we want to be with our numbers? Sometimes haven't you picked a number when you were doing long division with numbers at lower school or middle school that it was really too high and you had to go down some? Like if you thought maybe 48 times 2 would be the right thing, but then it was too big to subtract, so you had to do 48 times 1. Do y'all know what I mean?
I know.
I'll show you. Let me change this. If you're taking notes, just pause and don't write anything down. Suppose this had been 14. And I thought, oh, well, I'm going to multiply by 4 because I'm kind of thinking 10 times 4 is 40. Y'all see what I mean?
Yeah.
So if I put 4 here, that ends up being 56. That's too big, but at least I tried, right? And now I know I need to put in a what?
Different lower number.
A 3, and it'll probably work. Do y'all see what I mean? Okay. So, girls, I love that you're helping each other, but I would really super pay attention right now. The only time I'm going to do one of these, okay? So we're loosely thinking
Wait,
10 goes into 40, huh?
You're recording, right?
Yeah,
Okay, cool.
I think so.
I just wanted to double
The
check that.
record button's on. Okay, so 10 goes into 40. I'm just sort of matching the 10 and I'm not even thinking about the 42 right now. I'm just getting as close as I can, and I put in 4. Then once I decide on 4, don't I really have to go multiply it back and figure out what the number really is? And so I'll put in 40. And then what do you do in long division?
Subtract.
All right, 40. So you subtract, and you have 2, and then you bring down your 1. Immediately, what's your thought? You need a what? A 2, because you're trying to get close to 21, okay?
Do you add it to
So-
a number?
You multiply.
Like, does it become 21?
Okay, now you just say 2 times 10.
But when you break down the 1,
It just becomes part of the number.
Then I
this becomes
subtract.
part of the number.
It just like it was 4.
One.
It's
So
okay.
weird.
Just push it.
So then you do times 1.
My big point here is once you decide on whatever number you're going to put up here, don't you really go back and completely multiply it times that? I feel like I lost some of y'all in that, so I'm going to do another numeric one. And everybody watch, because there were some interesting questions that came up. But if you can get it with numbers, it's so much easier to do it with polynomials and what's called a rational function. All right, so let's say I have 132 into 556,000. Okay. What's your first thought of what you want to multiply by? And how do you make that decision? I'm trying to get this into this, right? So what are we going to try first? The answer?
4.
I would probably even maybe try 5 first. Y'all see what I mean? I think Nazareth suspects 5's maybe a little too big, but you're kind of loosely just going 100 into 500. Okay? So if we tried 5, and I actually don't know, 132 times 5. Yeah, it's too big, isn't it?
Yeah.
All right, so then we're going to back it down, but my point is, I'm trying to match this with this, 100s into 500s. So we're going to back it down and put in 4. It's going to be 528. Then what do you do? Subtract to see how far off you were. So you bring this down. I do a really weird subtraction, so just ignore this. I can't do the other one anymore once I learned Austrian subtraction. Now I'm like brain freeze. Yeah, I saw it in a book one time, and now I can't go do it the Bardo way. Like I've totally forgotten.
What is it?
Is that 538 or 428 on top?
That's 28.
28, then it
Yeah.
should be 389.
Oh, thanks. See, I can't even do any subtraction. So thanks, Nazareth. 132 times 4 is 528.
Oh, wait, I'm sorry.
I think it's right.
Sorry.
Because if you
Right,
if you add these two, you should get 556. So that would be 16.
right.
Okay. So, but always check me. I make lots of mistakes. Now I'm loosely thinking I'm going to try 2. Do y'all see? I'm just thinking of 100s into 200s. So I'm kind of lackadaisical at first, and I go, oh, I think I need about 2. But then don't I have to then go back and multiply it times all of that and check?
Yeah.
So once you decide on your number, you have to slam it all into that, okay? Which becomes 264, so that worked. Then I'm gonna subtract and bring down my 6. Again, I think I need a 2. Do y'all think I need a 2? But my quick decision was the 100 into the 200-ish number. Then I would have a remainder. I'm not gonna go any further. But did y'all see how I'm thinking 100s into 500s?
It'd be 258. Is what you bring
Oh,
down.
I didn't bring that down, thank you. So I probably should go further. Sorry, Dakota, you're right. It's so off kilter over here on the right of the board that I didn't see that from where I was standing. I would bring down my 8 and then put in a 2 and then keep going, okay? So one more thing before we go on. And don't say it out loud. I'm gonna let everybody decide on what number you wanna start with, and then I'll call on somebody, okay? You don't even have to write anything down, you're just looking. All right, okay, don't write anything, don't touch your calculator, you're just looking at this. And real quickly, raise your hand if you have thought of a number you want to try first. All right, Julia, I saw your hand first.
5.
Okay, why not 6?
Because there's like 42 at the end. Like I was doing like adding in my head.
So you're kind of thinking that 6 may be too much.
Yeah.
Was 6 your first thought? And then you
Yeah.
just said, okay, that's my point. 6, I wanted your first thought. It may not work, but I want your first thought. Did y'all see why my first thought is 1,000 into 6,000? I'm ignoring all the other numbers. Then, of course, in experience, we've kind of learned we usually kind of pick too high. But I honestly don't know. Julie, you may have gone farther with it than I have. Let's see, this is 12, 25. Yeah, it's going to be too big, so we're going to need 5. My point is, once I decide on a number, then I actually have to multiply it to all of those to check it. Do y'all see what I mean? Watch
Yeah.
this. I'm kind of matching this with this just to get me started. And that's what we're doing. All right, so let's go back to this slide. I think it's up here. All right, so this is all you got to do, like literally, okay? In fact, to me, this is easier than number division. I like polynomial division better than I do number division. I don't have to make that as too big as too little, okay? I just got to get an x to be an x cubed. Some people wonder, don't I care about the -2? Well, I guess on the 1,248 or whatever number I had, yeah, I care about it, not quite yet. I've got to make some decisions first. So to get x into x cubed, what would you use? Good, x squared. I don't care where you write it. Once Mia and I have made that decision, though, then we actually have to see what we got. Do y'all see my comparison with numerical? So now I'm going to go see what I got. I got x cubed minus 2x squared. Okay? Dakota?
Wait, so why do you get 2x squared though?
Once you decide on what you're going to put up here, you've got to go back and multiply it to that whole thing.
Right, okay.
That's what I was trying to show you with the numbers. Like this may say 132, and I think, oh, I need to multiply by 6 to get up in the 600s. But then I have to actually see what my number is. I would go back and multiply it to the whole thing. Anya?
Okay, for the next step, which is like the subtracting of that, I just get confused. I don't know if I'm overthinking it or what's going on, but if you're subtracting, well, I don't really even know how to phrase this, so I'm just confused. If you do minus 2x squared from negative 4x squared, would that be negative 6x squared or negative 2x?
Negative 2x squared. But to avoid that problem, and some things like videos that you look at and stuff, even the one I gave you, they just do it in their head, which is, I'm going to make a mistake. And don't just do this, because you'll be prone to just subtract the front one and not the back one.
Yeah.
So I'm going to write some down. If you're taking notes, I would say don't write what I'm about to do, okay? I find that I make the least mistakes when I do this. Do y'all understand I have to say this minus all of that? Okay? But our danger is we just cancel those out and we mishandle this, okay? So what I do is I have a whole lot easier time adding. So what's the same thing as subtracting is adding the opposite, right? What's 5 minus 3?
2.
What's 5 plus negative 3? 2, okay? So same thing. So what I always do is I distribute this, okay? So that becomes a minus, and what does that become?
Plus.
Plus. So I'm in the total habit of doing this. Not that. I don't even know what just happened. Go away. What? Okay. All right. So, and the other ones I'm going to go a lot faster through, by the way. So really pay attention on this one like you are doing. Thank you so much. So what I do, Anya, is now I know I want to subtract those. So I go ahead and go, this becomes a minus and this becomes a plus. And then I actually add. All right, these obviously cancel. They have different signs.
Do you not distribute on the top though?
Well, you're saying this number minus that number. Like, you know, in number division,
Yeah.
you wouldn't make the top. You know how you have 9 and a 6? You just say 9 minus 6 is 3.
So you're doing -4 plus 2x.
Yeah, it's whatever's there is whatever's there. Very good. So that becomes, you can see it better on your -2x squared. Okay, don't do anything to the top, but you never do. It's just like numeric division. What do we do next? Bring down, right, Alex? So I'm going to bring down my 2x. And then don't get overworked. I think that's where some people like really freak out about is they're trying to get it all perfect on your first guess. Okay? Like you're trying to turn that into completely that. You don't have to worry about that. Just try to match up the kind of lazily match up the fronts. Okay? So how I'm going to get that x? Don't worry about the -2 for a minute. How I'm going to get the x to be the -2x squared? I need a -2x. Now, once Nazareth and I have decided on that, I've got to distribute it. I've got to go back to the whole thing over there. Okay? So we get, that was times -2x. I'll write it right here. And so I've got to distribute it. I get -2x squared, and that's going to give me plus 4x. All right, and then Anya, I change my signs. I subtract. What's going to happen if I subtract that? It's going to become a plus. I just change both. I change whatever signs. If it's positive, I make it negative. If it's negative, I make it positive, and then I add. These cancel, and I get -2x plus 5. All right, now, most of you have gotten it. You're trying to get x to be -2x. In numeric or polynomial division, you're just trying to match up the fronts and then see what happens, okay? What do you need to get an x to be a -2x? You got to match it exactly, not just 2. You want x to be -2x. I want this x to be -2x. I'm trying to match the front up. I need a -2. Okay? All right, so I'm going to write a -2 up here. So this is, now I have -2. And now I've got to go back and multiply it once I've decided on it. Once I put a number here, just in numeric division, I then have to go back and see what I really got. So I'm distributing it back here. And I get -2x plus 4. And then I'm going to change my signs. This cancels, and I have a remainder of 1.
Wait, so you always change the
wouldn't
sign?
just be
You're always subtracting.
Yeah.
So what happens when you subtract a positive? Well, what happens if you subtract a negative? So I'm subtracting, like I'm looking, I'm going to subtract this one. It was a minus before I did that. I do. You can do your own way, but most people that try to subtract in their head mess it up. So I just look at it. Like I just actually throw it in front of my face so that I don't make a careless mistake. Anya?
Can we do parentheses where like on the test or something, is it fine if we do like parentheses and put minus outside of that and like distribute it? Like the way that you did it the very first time you showed us, like right
You
now.
mean writing
Yeah,
the
like right
answer?
now. Like not
Oh.
writing the answer, like just when we're showing our work, is that fine? Because you just like changed it, but then it's
Like, can we distribute the minus sign on a test?
is that fine?
I would do it like I'm doing right here.
Yeah, that's what she wants.
Like with
No,
the,
she
like with this.
Yeah, that's fine.
Adding the parentheses,
Not like
and then the
Okay.
parentheses.
Yeah,
minus.
like introducing it, I'll show
She did
you.
it once and she
Anya.
said,
That's
never
what she
mind.
did.
Yeah.
Yeah, you pick whatever works for you as long as you get an answer right.
How
Okay,
do
this is, if you like this is what I do myself.
Okay.
The first example Dakota was showing me, I put a minus with the parentheses, and you don't have to do it that way, but that's just what you're doing when you have that. That's kind of what you were asking, Ava, the first day I did it, I had something like, 2x minus 6, that's a 5. Oh, 2x minus 5, minus, and I put like parentheses around it. And maybe I had underneath it 2x plus 1.
Yeah.
But today, what I'm doing is I'm just going ahead and distributing that negative sign all the way through, so I can see the whole thing happen.
Okay. And
Okay.
it's just because it's x minus 2, or just because you're subtracting in general?
Once you put something underneath any kind of
Yeah,
long
it's
division,
always-
you've got to subtract those two. It's not because anything happened up here. It has nothing to do with what you put at the top. If you think of your
I
numeric
thought it was the
division,
x minus 2 over there when you multiply.
doesn't matter.
Okay.
Doesn't matter. Oh, by the way, girls, one thing that has to happen in pre-calc is x minus 2 actually is a number. We just don't know what x is yet. Girls, if x is 7, I don't know what it is either. But once I give you an x, if x is 7, this just becomes 5. You're just like, in fact, that's going to be fun to do. Watch this. Okay? How about we let x be 3? Okay? So let me grab this.
How do you write the remainder?
You can just go R
Okay.
or just leave it down
So,
there.
like,
for-
with the answer
because
to be
my
X
job
squared.
this year actually is not to teach you long division. So you're not even going to be like, you'll be doing it on the test to answer a question that I teach you in hopefully today.
Okay.
So
Okay.
you would just write.
But I just know every year people need to stop and do long division. Okay.
Okay.
So you
But you can do whatever you want to off to the side to answer the question that you need it for.
So you could do like x squared minus 2x minus 2 r
Yes.
1 over x minus.
Oh,
6.
don't do both of those. If you use the R, you just write
just write R.
R1.
Oh, okay.
If you do the over, you don't write the R. Okay?
Oh, you don't have to write the over?
Not if you do r like r1.
You could go remainder 1. Yeah.
I like that.
Y'all okay? Yeah, me too. Yeah. All right, watch this. I'm going to just let x be 3. There's no reason for me to do that right now. I don't want x to be 3. I changed my mind. Let's let x be 4. 4. All right, there you go. 4. Now I'm filling it in here. This is not something you have to do, so this is for your viewing pleasure. You do not have to copy this down. I would just sit and watch this. It's just like kind of a proof, okay? Or an interesting thing to look at. We all hate the word proof, probably like we hate the word fraction. But anyway, I'm going to just
I
fill
hate
in
the word
4
factor.
because I wanted to, all right? 4 cubed is 64 minus, this would be 4 times 4 times 4. And so that's also 64. Plus 2 times 4 is 8 plus 5. Divided by 2, okay? So this cancels out, and if, I don't know what x is, like I was telling Ava, but suppose it's 4, then the answer is 13 over 2, okay? Now let's go back to our answer that we got, hoping that I did it right with all the stopping and starting that we did in that problem. Our answer, we got x squared, well, you can tell me. For our answer, we got x squared minus 2x minus 2 with a remainder of 1. Is that right?
Yeah.
What was our x for our little prototype here? 4. All right, so let's fill it into our answer. Because we said this is our answer. If we put in 4, we'll get 16 minus 8 minus 2 with a remainder of 1. What's that, 6? And how would you write your remainder? You really would write it as a 1 over the denominator 2, right? Guess what that answer is?
Because it's over.
13 over 2 is 6.5. What if you had chosen 10 for x? You'd have gotten a different answer, but do you see if I fill it in as a number, I get it all works just like numbers. We're just having to do it because we don't know what x is. Because x can be anything. All right, I'm going to fly through the next examples. In fact, after I answer Dakota's question, I'd say don't even raise your hand, please, okay? because if we spend all that time on number 2, you really won't learn. If you just let me skate through a lot of them, I think that you're gonna go, if you watch me and watch me and watch me, I'll go slowly enough to take notes, or if you're frustrated with my speed, you can slow me down online and rewind and everything, okay? But I think if I get a bunch of them in front of you, it's gonna be a lot more effective than doing one more slowly. So, do this. You may have a very valid question. I'm sure you do. But you're all paying great attention. Write it down. Write yourself a note. I do that all the time when I'm listening to a speaker and I want to ask later and we're not taking questions, okay? So write down your question. My guess is when I'm finished with a bunch of examples, you won't have that question anymore, but if you do, I'll give you a chance to ask it, okay?
Can I sit in front just to watch?
Can you what?
Can I sit in front just to watch?
You can do, yes. Dakota, your question.
Yeah, I was just wondering like how, like, is this gonna be like the hardest it's getting, or
Yes,
is there
yes,
gonna-
yes, yes, yes. Okay, so next example, and I'm gonna fly through I may not even do them all, we'll just see how we feel. All right, so this one's gonna be, Harry's on here somewhere, we're not gonna find him. 12x cubed minus 11x squared plus 9x plus 18. Now, you'll pause and think to yourself, as you're writing it, you'll ask yourself, is it going 3, 2, 1 number? Everything's accounted for, divided by 4x plus 3. I'm gonna go really fast. Your job
Oh, this is number 5.
is, oh, I'm sorry, did I go out of order?
Yeah, I think this is number 5.
Thanks, sorry, my screenshots must be in a different order. Okay, so it's number 5, the girls have said, all right? I'm just matching up this for now. Later I'll go back and just like distribute it all, but I'm just gonna make a quick snap decision. I think I need a 3x squared. So I'm gonna write down 3x squared. Once I make that decision to try to match it as closely as I can, now I've gotta go back and distribute the whole thing, okay? So I'm saying 3x squared times 4x is 12x cubed, and this will be plus 9x squared. Then, as Anya and I talked about, I always just change my signs. This cancels, and I got negative 20x squared, and I bring down my 9x. Then I do my match again, just the front, just like you would with a number. I need a negative 5x. If I do a negative 5x, that turns that into a negative 20x squared. And just with your, like with your numbers, you need to see what else is back there. So negative 5x times 3 is negative 15x. I'm going to change my signs. Minus and negative's a positive, and that one's a positive. Those have different signs. They cancel out. Add those, because you're really subtracting a negative. You get 24x. I'm going to bring down my 18. I'm going to make a snap decision. 4x times what will give me 24x? I need a 6. Once I make that decision, though, I need to go back and flesh it out and build what I'm going to have. It looks like 24x plus 18. Oh, interesting. 24x plus 18 has no remainder. In a little while, what's going to happen is you're going to do long division to find out what your graph looks like. And it's going to be a guideline. What I'm building up to is you kind of, not really, but you sort of feel like, vertical and horizontal asymptotes. This also is the slant asymptotes, which you did in Algebra 2, but I need to move on through. I'm going to do one more. I'm not going to do them all. So let me.
Can you scroll up a little bit more?
Yeah. And remember, this will be there. I'm going to do a real important one next. Okay. I don't know which one I'm going to get, but I'll just grab one if I don't like it. Okay, this is a good one. All right, so now I'm going to say 2x cubed plus 4x squared. What's missing? X. So you need a placeholder, so you put in 0x minus 5. Sometimes they even have to put a placeholder on the one underneath. It doesn't happen often, but watch for it. If it skips something, you've got to put in a placeholder in the dividend and the divisor, numerator and denominator. All right, but it's just 1 and x to the first minus 3, so it's good to go. X plus 3. if I can move that over. Why is that not going away? Auto hide. Well, now it's still off the screen, so let me fix this. So this is x plus 3. Alright, so x into 2x cubed, I'm going to need a 2x squared. I go back and distribute 2x cubed plus 6x squared. They're both positive. When I subtract, they'll both become negative. Cancel, that's negative 2x squared plus 0x. X goes into negative 2x squared, negative 2x times. Be sure you multiply by a negative 2x all the way through. Negative 2x squared minus 6x. Oh, this one's weird. Oh, this is a 0. Okay, because I brought down 0x. Then I'm going to subtract, so that's plus, and this one's plus. Cancel, and I have 6x minus 5. So I need a 6. I need a 6, and that gives me 6x plus 18. 6x plus 18, and then I subtract. That cancels, and I think my remainder, if I did it right, is negative 23.
Can you have the R and then a negative number? Is that allowed?
Your remainder can be positive or negative, or 0, but there's no reason to write it down.
And I saw in the previous one you did r dot whatever the remainder was. Is that necessary, or can you just write r negative 23 or like r?
Oh, you don't have to have a dot.
Okay.
Okay, now look at this one.
Yeah.
Let's see. I'm sorry, did somebody say something? I didn't hear you.
I don't know if this is what you're about to do. The one with the like 3 like numbers to divide by.
Oh, maybe. I don't know which one where it is in the screenshot business. That's not it. That's the first one I started with. Do you know what number it was?
Number 3.
Is that it?
Yeah.
I'm not going to do that whole one out, but I'll get started. I would start this out as 2x cubed plus 7x squared minus 4x plus 7. Ava and everybody else, you want it in descending order. Do you see how I went x to the third, x to the second, and so on? Anybody? Everybody?
Yeah.
Alright. So this is x squared. I love being able to write on the board, but it's not very oriented. Alright, x squared plus 2x minus 1. It doesn't matter. It's just like, Ava, you asking me, like, what if I divided by 23 or 231 or 2,314? It's the same old process, just like with numbers. You match this up. You and I are going to need a 2x in here. Okay? And then I go back and multiply times all 3 of them, just like I would if I had 3 digits. And that gives me 2x cubed plus 4x squared minus 2x. Ava and others, is that okay?
Yeah.
Okay, then you subtract and just keep on going.
Got it.
And try them. You know, they're
So there'd be like less steps though, because there are 3.
you're gonna, well, it depends on how long the thing is you're dividing into, but that's a great point. In fact, I want to go on because I'll come back to this problem in a minute. So now I'm going to subtract minus plus, gone, 3x squared minus 2x plus 7. I'm going to need a 3. Now here's great news. This is where we're headed. Great news. Everybody's listening because you want to hear good news, okay? It's super good news. What you're looking for is if it has a slant asymptote, which is a line. An asymptote is a guide line. Do y'all see a y equals mx plus b up here? Y equals 2x plus 3? So you don't even have to finish this. Once you find your guide line, you can stop. once you see 5x minus 7 or 1/2 x plus 4, you've got a line, okay? So now I'm gonna finish though, just to show you something. 3x squared plus 6x minus 3. This goes minus, minus, plus, cancel, negative 8x plus 4, 10, sorry. And I don't want to open iTunes. All right, so plus 10. I don't care what the remainder is, okay? You might care what the remainder is for a reason that I'm going to show you, okay? Did I make a mistake? Or you just have a
No, I
question?
just have a question.
Okay.
So when you're using long division, as soon as you get the y plus b count,
You're done for me, for now.
Okay.
For what I need in pre-cal.
Oh, wait, but how do you know when to stop? I'm just gonna.
Once I got a 2x plus 3, I was done.
Because that's
once
once
you
you
get-
get, so basically once you get a number at the end that doesn't have a variable in it,
Then you're done.
All right,
Yeah.
so, well, that's why I say let me keep on teaching. Y'all are so sweet to ask all these questions. You'll see. Let me just keep on keeping on. But I can't fault you for having lots of good questions. You're paying great attention. All right, now, one thing that I want you to notice, now we're going to graph this. It's going to be an insane graph maybe, but so maybe not the best one for me to start reminding you about asymptotes with, but we've gotten this far, and so we're going to keep going. Or maybe I'll come back to it, but I'll just show it to you with this. Okay, time out. Up on the very top of that other slide, did y'all see, was it 2x plus 3?
Mm-hmm.
That's going to be my slant asymptote. Slant asymptotes occur when the top is 1 higher than the bottom.
Wait, okay, like it would be like 7 over 6.
I'm going to show you. Where the top exponent is 1 higher than the bottom exponent.
That's a slant.
That's his bottom. Okay, I'm not going to try again, okay? Bottom. It says bottom, all right? Do y'all see this exponent? This board.
It's the exponent though, not the number.
I'm going to point with my cursor. Do y'all see this exponent and that exponent? What's another word for exponent? It's the third power. They have a lot of power. They're holding all the power, okay? So the coefficients matter a bit, but those powers matter a lot. Here's the good news. There's a lot of good news here at the end today instead of all that drudgery at the beginning. The good news is you're going to look at this and go, oh, a quick mental division in your head. Do y'all see right here? If I go, you know what, I don't want to do all of that. It's like, you're going to have to, by the way. But you're like, I don't want to do all of that. That's really yucky. I just want to know what the graph is doing. What happens if you have 2x cubed over x squared?
It becomes 2x.
It becomes 2x. And then you can get more clear by your long division. But what Kate and I know is if
How
you
is
look
that
at
possible?
just a minute. What you've been trained to do, except for in part of Algebra 2, where you've done some of this before, is most people think of mathematicians look at things under a microscope, but they're also excellent and maybe hard more to look at the big picture. But the only way I'm going to know the big picture is I've got to be really good at analysis. An example of that would be one I've probably given you if you were in my class before, is say that you were let's say Alina was my CEO and I'm the CFO, Chief Financial Officer, which sounds super important, but the CEO is the Chief Executive Officer, and so she's my boss. And I make a lot of money, but she makes a lot more money in our little company. So as the CEO, she has told me to go, you got 2 days to figure out our budget for next year. Because it's September, getting close to October, we need to put a projection for starting in January. So only way I'm going to have a good projection is to be really good at numbers and crunch our numbers in sales and revenue and cost and spending and rent and y'all see what I mean? Like I got a big job ahead of me. So what if I do that, and obviously she's hired me and paid lots of money, so I must be good at it, and that's what she's paying me for. And I find out that our budget for next year is $13,428,922.13 because I've actually crunched all of the numbers, and that's what's at the last column of my Excel spreadsheet. And I go into Lena's office and I go, excuse me, I have our budget ready. I put my report on her desk, and she goes, what's the report, what's our projection? Because she's got to take phone calls and move on. And I go, well, it's $13,428,920.13. She didn't even hear that, and plus she's rolling her eyes like, I know she's good at math, but she drives me crazy. Like, what does Alina want me to say?
$13 million.
$13 million, or maybe it's about $13.5 million. You see,
Like 13.4.
now she knows I better have it right on my report, though, right? Or people can go to jail for things if they misreport. Okay, she wants my report to be right in case we're audited. She don't want to hear that from me. Do you see? She wants the big picture. Okay. Yeah. If I say $13.5 million, and she goes, well, is it higher or lower? We might have a quick conversation, and then she can look at my report. Do y'all see what I mean about I got to be good at the big picture and the little picture? If you've ever flown, you've looked down at the ground and gone, oh my gosh, that's so geometric. Like, I didn't know that was happening down there. Maybe. I don't know if you've looked out your window and seen it. There's also super cool things. Like if you go to so many stores now, like FAO Schwartz, I saw them at Barnes & Noble the other day. Certainly at the Lego store, because what I'm building up to is Legos. Like if they've made Winnie the Pooh or Darth Vader or something like that. If I'm standing right up next to the Legos and I see they put a blue one here and a black one here, I can't tell that it's Super Mario until I do what? If I back away from like, oh my gosh, they built Super Mario. Do y'all see what I mean?
Yeah.
So you have to be good at both, but the people couldn't be good at what they wanted us to see if they didn't know all that crazy detail. Asymptotes are about the big picture. That's what I hadn't gotten out of my mouth yet, unless I said it to you in algebra 2. If I zoom out on this, I have these guidelines, like this framework that I want it to look like, okay? So let's talk about what my guidelines would be here. You've got to be able to factor, which hopefully you won't have to work on too much. I'm going to factor the bottom, which is x times x. Oh, that won't factor. So forget that. That won't factor. Let me just show you where I am right now. Let's look at this graph. And then we'll do some concrete things.
Can I use the bathroom, or is something really important?
It's all really important, but that's a good thing about me recording. You can notice that, maybe when you were gone. We're right here on this slide, and I'm pulling up the calculator. So if you want to go to the bathroom. Okay. Yeah. But, kind of notice where it is, and that way you can only watch those little bit of time that you're gone. All right. I'm going to type in my y equals 2. Oh, I need parentheses, girls. By the way, when you're doing these, use parentheses. 2x cubed minus 4x plus 7x squared plus 7 divided by x squared plus 2x minus 1. By the way, I know I just skated over factoring. I just scooted right by that. And some of you are like, I love factoring. Some of you are like, oh no, like she's going to think I'm great at it. I got a really good way that your teachers have already told you that I'll reiterate, where you can even know ahead of time if it'll factor or not, like I just did. I'm like, I'm not going to bother, it won't factor. I'll show you that later if you don't remember it. All right, Zoom 6 on the standard viewing window. It looks kind of crazy, like, whoa. You kind of remember those in the background? I'm going to also type in our slant asymptote that we got from long division, 2x plus 3. Now, in crafts, I think I talked about crafts in the last class, like folding up, I can't remember the last class because I'm in so much pain, but
Yeah,
you talked about, and all of ours may not look exactly alike if we made a craft, but we look around the room and go, oh, that's really cool, because we basically did it all, okay? There are people that I teach, we will not name them. Really, nobody in this room that I know of is like this, where if I said, here's your craft, and it had cut on the dotted line and fold on the solid lines, that you would need, can I have another sheet of paper? Can I have another sheet of paper? Because you felt like you didn't do it like right perfectly.
I'm like that.
Okay? But the rest of you would be okay with cutting close and folding, and it's kind of not even different from your friends, numbers, right? Asymptotes, people follow asymptotes, okay? When I go follow me, you might be right on my footprints in the snow. Or I might just look behind and go, yeah, thanks for following me, unless you just wandered way off somewhere, okay? They're guidelines. I don't like the word asymptote, it's a guideline, okay? Watch this graph. All right, so here's my graph. That's all the yucky fine detail that you'll have to do. You'll have to be the CFO, okay? But watch this. That's the graph we're trying to do. And here comes the asymptote. Follow me.
Can you make it bigger?
Maybe.
Zoom.
You're not gonna have to zoom. I'm just showing you an illustration.
Sorry, it's fine, I can see. Oh, there we go.
It's doing
Wait,
something.
where is that line?
I'll put it in 2x plus 3. You know, I'll put in our answer.
Wait, red is the asymptote or the guidelines?
Yeah. Is there 3 lines?
Red is the guideline. Oh, it's not 3 lines, it's one graph that's made up of a bunch of different stuff. You know, like a piecewise graph?
Yeah, but I'm just trying to see, is that a line that's kind of going down? I just can't really see.
Why is it? It's not responding to what I'm asking. Just a minute. Let me just change the window.
Oh, the denominator. And then you factor. Got it. Ah ha ha.
All right, girls, look. Don't miss this. Don't miss this. Don't miss this. Don't miss this. The blue graph has a lot going on. I'm going to zoom out one more time. Here's our blue graph. And here's our red graph.
Oh, one right through here.
From an airplane, they're indistinguishable. Okay, so I'm going to give you one more example of what's happening here. Our dress code is a guideline, okay? And I may have already given this example in my pain on Thursday, okay? But it's a good one, so I'm going to give it again, okay? We're all standing out, and you see New Yorkers trying to get to the Met or whatever they're doing and have to walk around us or grumble sometimes or whatever. But if somebody stood at the end or across the street and looked at the preschoolers or at us, they would go, oh, their uniform must be navy and white with a light blue skirt. Okay? Don't you see that's like a big picture? And that is our guideline. That's what we tell you when you come here. But if they started walking up to some people, especially during, like if it's a mass day and they go, oh, they have to all wear knee socks. If they got up closer to class whatever, they'd realize, well, maybe not everybody's doing that. Do you see the difference in the big picture and the fine detail? I got to know both of them. But do you see that that blue graph did follow the red graph? Eventually. Big lesson today. Life doesn't exist in a negative 10 to 10 viewing window. What I mean by that is there's some interesting stuff trying to misbehave in the negative 10 to 10 viewing window. All that stuff you saw doing this are people that are in their sneakers and their no socks and whatever that they're, you know, not supposed to be in on sweatshirts and who knows what else, okay? So, let me do a problem. Let's do, and I'm keeping an eye on the time. Let's see. This one's really funny. So, we'll do this one. Let's see. Okay, now I am on, I'm on the vertical asymptote homework. Okay, those of you that really read the sheet and tried it, now hang on and watch what's going to happen. In fact, I'm going to institute I'm gonna really, it's really hard for me because I am so nice. I know that sounds weird. It's not like I said I was pretty or anything. I'm just really nice. And I have a hard time not answering your questions because I've also got some teacher built in my DNA. But I'm not gonna answer your questions, just let me talk, okay? So, we'll see how long that lasts. Number one, this is what you need to know about number one. Some of you maybe don't have this worksheet. Some of you may have printed it off or looked at it online. This is, and you wouldn't have done everything probably that I'm gonna require you to be able to do. But after this example, hopefully you will, okay? A vertical asymptote, first of all, you look at vertical asymptote. Some of you know it's what makes the bottom 0. A caveat to that is it can't make the top 0. It might be a hole in the ground, okay? I think I talked about Thursday, some things are badly broken, some things are just chips. Did we talk about that a little bit? Okay. So anyway, the vertical asymptote here is at x equals -4. Do y'all see it makes the bottom 0? If I do a quick fill into the top, it does not make the top 0. And if it did, I would erase the vertical asymptote. It can't be both, okay? So you have x equals -4. Please draw as you find things. All right, so that's my vertical asymptote is x equals -4. I kind of missed it over there because it's not oriented, but anyway, okay? Now, it has a slant asymptote. How in the world do I know that?
Because the exponents
I don't know
are
what
one
just happened.
different.
Very good. Kate's highest exponent, this one is one higher than that one. That's the only time you have to do long division. If the top's not one higher than the bottom, you don't have to do long division. I just knew I had to stop and go over it. I'd love to think in pre-cal I could have said on Thursday, oh, the top's one higher than the bottom, do long division and keep on going, but I knew that wasn't gonna happen. So now
So
we
it
have
has the
pause.
horizontal
I'm
and
not
the
answering
vertical?
questions, write it
Okay.
down. I hadn't gotten the horizontal yet. X squared minus 2x plus 0 divided by x plus 4. I only have to do long division if the top is one higher than the bottom, okay? X goes into x squared, x, so that gives me x squared plus 4x. Then I'm going to subtract, cancel. If I was writing clearly, that would say -6x and bring down your 0. Now what do you need to get x to be a -6x? -6, you're done. Do you see a y equals mx plus b? Your slant asymptote is y is equal to x minus 6. Let's draw that in. Y is equal to x minus 6. 1, 2, 3, 4, 5, 6. Reminder of graphing lines. -6 is my y-intercept. My slope is up 1 over 1, up 1 over 1. So it's like follow me off this way. I don't know why I drew that so big. All right, now, asymptotes are your friends. I'm going to draw it over here, sorry. My vertical asymptote was -4. My slant asymptote was y equals x minus 6.
Wait, Mrs. Ariel?
No, write your question down if you have it. I'm not answering it. Which sounds so rude if gosh, what if a tour came in? Oh my Lord. Okay, so put in your guidelines because you want your little craft to have your dotted lines. Okay? Now all I've got to do with those is find some points. I'm going back up to this, which you'll put in your calculator, which I think I have time to do. Okay, so in my calculator, I don't need that anymore, I'm on a new problem. I'm going to go parentheses, x squared minus 2x divided by x plus 4. I tell you what, when I'm doing these, the very last thing I do is hit graph, okay? All right, so I'm going to go to table. Does everybody know how to go to table?
Second round.
Did we set up your table the other day?
Yeah, with the ask.
So now I can put in, I don't need many points now that I have these asymptotes in place, okay? I'm gonna fill in 0 if I can, let's see. 0 gives me 0, so I have a point here. So I have a point at 0, 0. Now I'm gonna find another point. I should have gotten y'all to put it in so I can go back and forth. Now I want to fill in just some numbers around -4 and 6. Those are my two things. I'm going to fill in 1. 1 gives me -0.2. 1 is -0.2. I'm a little surprised at that. Now I'm going to fill in 5. I'm just picking numbers. There's no rhyme or reason to this. I'm watching the time. Now I'm going to fill in 5, and I get 1.66, 1 2/3. So it's not simplified 5, it's 1 2/3. So, and now I'm going to fill in something back here, like -5 or -6. All right, so I'm going to fill in -5, and I get -35. Okay, so I'm going to fill in -7 because I don't want to graph -35. It's way down here. So if this is 6, I would have to keep going way down. Somewhere down here, there's a graph that's following that off. All right, now last thing I'll do, and I'll tell you what to do for homework, is I will show you this. Just hang on, you're doing great. T-I. Okay. So now I'm going to go to graph. I'm going to hit zoom 6, which takes me back to a standard viewing window. Do y'all remember that piece that I got? It was only undefined at -4. That's why table's so powerful. I don't even see the other piece.
But you know that it's there.
I know it's there. Not only do I know it's there, table told me it was down in the 20s and 30s. So I'm going to go to window and go down like to -20. Or -30 probably, and hit graph, and you'll see what you already knew was there. So you're not struggling changing your window because you already know your asymptotes ahead of time. Okay, I'm gonna, I don't even think I posted your homework, but let me give you what I copied for you, and I am gonna postpone our test. I don't really feel good about, we're in a great place, but Miss Arkin's class might still have it on Friday, but I'm going to wait. So I feel super good about this. I think we can spend Wednesday and Friday on this in a more calm fashion. I
agree.
Now I don't have
So I'll have to check the calendar, but probably the next Tuesday. But I don't know what's on the calendar, so we'll see.
enthusiastic.
That's so kind, Mrs. Larry.
Let's see, don't do all of this, just read online. What I want you to do is front and back, but bring it to class and do the parts I tell you to. You honestly won't have that much homework. You'll do parts of this and we'll do it in class, and I'll give you some activities with me letting you watch you work. All right, girls?
Thank you.
Okay.
Thank you so much.